Welcome to today's webinar, Configuration Management with AWS OpsWorks. Our presenters today are Amir Golan and Thomas Cashwig with Amazon Web Services. Today with us we also have Mikhail Allenbeck, and they will serve as our webinar moderators and will engage with you and answer your questions throughout the presentation while Amir and Thomas present. Amir and Thomas, welcome. The floor is now yours.
Thank you.
Hello.
And welcome everyone. My name is Amir Golan. I'm a product manager for Amazon Web Services, and I'm here to talk to you today about configuration management on AWS using AWS OpsWorks. Before we begin, there are several definitions of what configuration management is, but we'll talk about some of those in the context of OpsWorks and in general. So, to start things off, why would you need something like OpsWorks, or in general, configuration management? So, OpsWorks in itself gives you something of ability to group and model your applications. OpsWorks lets you define something called stacks and layers, where those layers equivalent to tiers, application tiers. So you can define how your application looks like, whether it's divided by microservices or by specific application tiers, let's say a database tier, a load balancing tier, a web tier. You can define those in OpsWorks, and again, those stacks and layers, which we'll talk about in just a little bit. After you define those logical constructs, you start filling them up with resources. In our case, those resources are most likely going to be instances, perhaps EBS volumes, elastic IP addresses. And once you define those resources and place them within those logical constructs, stacks and layers, you also start managing the life cycle. That means what happens to a resource once it gets created and once it gets stopped or terminated. You can control these and define these and literally specify these in OpsWorks. Now, another thing that you can do with those logical constructs, which we'll talk about in detail in a few slides, is you can define who has access to those specific logical wrappers. It could be an IAM user, for example, that's been given an access to a specific stack. Once you've defined who has access to a specific set of resources, which are part of a stack, you'll also be able to define logical monitors on a group level. That means you can monitor the state of your entire application resources that are a part of a specific stack. You'll also be able to get aggregated logs from that stack and all the underlying resources within that stack. And you can use those logs to mitigate operational problems that happen throughout the life cycle of your application at any point in time. So coming back to configuration management and how it applies to OpsWorks. OpsWorks, to those of you who know, uses Chef. And Chef is a tool that is used to configure the software that is installed on an instance or a server. Chef uses a Ruby DSL to provide you with common operating system abstractions. So what this means is you can define, using Ruby code, what is going to be installed, what sort of dependencies will be installed, what sort of patches, the folder structure, permissions, anything that you'd like to define on the operating system level, on the host level, and how your actual host is going to be defined, how it's going to look like. You can do that by associating something called cookbooks and recipes. Chef offers you the ability to run those cookbooks and recipes on the instances. So you predefine those cookbooks and recipes, let's say one that turns your server into a web server, another one that turns into an application, a Rails application server, and so on. You can define those recipes and apply them later on to the life cycle of your resources. Okay, and after you do this and you apply those recipes during the life cycle of your resources, you can see or you can define what happens to a resource once it goes online or once it gets terminated and everything in between. We'll see an example of that in just a little bit. So we'll start with how you can model and group your applications using OpsWorks. At OpsWorks, we have something that I mentioned at the beginning of the lecture, which is a stack. Now, a stack can represent anything. It can represent a project, a stage, an environment. It could be your production environment. It could be your staging environment, your pre-prod environment. It could be whatever you want it to be. And inside that stack, that could, again, mean anything to you. It's a logical construct that you define in OpsWorks. You have layers. Now, those layers represent application tiers. In this specific example, we're seeing an Elastic Load Balancing tier, a Rails App Server tier, and a MySQL database tier. Now, each of those layers serves as a blueprint. And in that blueprint, you assign those recipes that we've mentioned, that Ruby code, that will define how every single instance or resource that is provisioned in that tier is going to look like. That layer blueprint assures that every single instance that is provisioned within that layer is going to look in exactly the same way. It's going to be attached with exactly the same EBS volume size. It's going to also always have an EIP attached to it if you define to. And it's going to run the same Ruby recipes and every single time a new instance joins that specific tier. We'll talk about how you can control the life cycle of the resources within a layer in the next slide. So this is how it looks like from a console. You have layers, a specific set of, this is a specific stack, and you have 3 layers within it, just like we saw in the example. An Elastic Load Balancing layer, which is directly our ELB, or you can even set up your own, a Rails App Server, and an RDS database, all a part of your stack. So coming back to those life cycle of your instances and how you define those life cycle how you define the life cycle of your instances, OpsWorks lets you hook or build hooks for those cookbooks and recipes offered by Chef to specific layers. So every layer have these hooks, and those hooks get triggered every time one of these events happen. So to give an example, let's assume I have an application, which is a stack, and it has 3 tiers or 3 layers. Each one of these layers will have these lifecycle events: set up, configure, and deploy. There are some more, but we'll focus just on these ones at this point. I'm going to assign specific Chef recipes, those written in Ruby, to each and every one of those lifecycle events. So for example, the recipes that I attach to the setup event will be triggered every time the instance boots. So every time a new instance boots, it's going to run the Chef recipes written in Ruby on every single instance within a specific layer. And I'm going to use this lifecycle event normally to bootstrap the instance, install all the software dependencies, all the packages, build the folders, the permissions, whatever I need to make sure my application will be able to run on that specific instance. And again, every single instance within a specific layer will run the same exact setup recipes that are attached to this specific lifecycle event. We also have the deploy event. Now, the deploy event is also very special. The deploy event lets me manually define when I want to deploy a new version of my application. So every time, as a part of my pipeline, when I want to deploy a new version of my application, all I need to do is just go to OpsWorks and direct it to where the new artifact is. OpsWorks will go and retrieve that artifact and deploy it on these set of instances, which are part of a specific layer. And another lifecycle event I'd like to focus on is the configure event. Now, this configure event is triggered every time there's a state change within a certain stack. So let's assume a new instance just joined a cluster or a certain layer. A configure event will be triggered on all the other instances within that stack. And we'll give an example of how this looks like in just a little bit. What this means is I can define how my application is going to react to changes, to the introduction of new members or leaving members. I can define specific Chef recipes and attach them to that specific lifecycle event that will be triggered every time someone else joins a cluster or leaves one. And that way I can define 2 very popular use cases. I can define permissions or add repermissions to new members that join the cluster based on their IP or some other parameter, or assuming I'm running some sort of a cluster, I'm going to be able to attach new members or to react when new members are added to the cluster and notify all the other members that these new nodes in the cluster are now eligible to receive traffic. let's look at a new OpsWorks application that I'm building to demonstrate the use of lifecycle idea. So at some point in time, I have an app server that I define on a specific layer in OpsWorks. I provision a new instance. Once I provision a new instance, OpsWorks will do this, of course, for you. It will provision a new EC2 instance for you. It will install the OpsWorks agent on that specific instance, and it will get the cookbooks and recipes that are relevant to that specific layer. And now, those that it decides to run on the instance depend on the specific life cycle the instance is currently on. So in our case, I just booted up a new instance. That would mean the setup recipes will go in effect. So every single recipe associated with a setup event will now be triggered. After this is done and the instance starts to get bootstrapped, something else happens. As I mentioned before, every time a new instance leaves or joins a cluster, the configure event triggers. Now in this case, assuming I have configure chef recipes attached to the configure lifecycle event, they will also be triggered at this point. Let's say after this happens, I want to deploy my application. Again, I want to end up in a state where I have my application running. So in this point, I can just deploy my application. This will happen automatically on setup in any case. But I can, as I mentioned before, do this manually at a later point. What matters is after this deployment phase is done, I installed all my dependencies in the setup phase, and I deployed my application in the deploy phase, and my application is running at this point. Now let's assume I add a database instance. So when I add the database instance, this is of course done in another layer, and that layer has a complete set of different recipes that are attached to its setup, to its deploy, and to its configured lifecycle events. So it will run different recipes for setup, let's say to bootstrap MySQL, for example. So after this happens, just like before, another configure event is triggered. So that configure event can do a whole lot of things at this point, because now it has other members to interact with. It could shift logs. It could add permissions. Let's say I want my application server to now be aware of the fact that it has a database to talk to. The database, on the other hand, can add permissions to allow that instance to talk to it. I can basically define whatever I need to make sure every member is able to react to the addition or removal of other members, whether they are on the same tier or layer or from a different tier or layer. So now I can deploy a new version of my application. Now the deploy event is triggered on all the instances in the stack, but it's not necessarily relevant to all of them. So in our case, the database layer doesn't have any deploy recipes attached to it, and therefore it will ignore it, while the app server is going to deploy the new version of my application. Let's say I add another instance. Of course, this new instance gets the latest version of my app. I don't need to redeploy just like I did before. It's already updated with the latest version of the application. And just like before, it triggers a configure event. In this configure event, for example, the database can now add into the access list and allow that instance to talk to the database. Another thing I can later do, let's assume something happened to an application and I want to mitigate some sort of an operational event. I can run arbitrary recipes at any point in time across my entire stack or on a specific layer, in this case on the application layer, as you see only relevant to these two instances. And this could do basically anything. Either mitigate an event, shut down or restart a process. It could run a backup. It can push logs, request logs. And now let's assume I stop one of the instances, one of my application instances. So this could happen automatically. We haven't talked about this yet, but OpsWorks support auto-scaling based on load or time-based. And once this happens, and once the instance shuts down again, you probably can expect this by now, but again, another configure event, which can, just the same way the database added permissions to that specific instance to do writes or reads from it, it can revoke those. It can revoke the access based on the IP. So after we've covered stacks and layers and discussed about how those layers have their own individual lifecycle events, which we can attach recipes to, let's talk about some of the things that you can do on the stack level. So OpsWorks also lets you define control access management on the stack level. You can do something very, very unique in OpsWorks, which is take an IAM user and give him permissions that would apply all the way down to the underlying resources that it manages. So let's assume I define one of 4 types of permissions. Let's say one of the deny, the show, the deploy, and the manage. Any one of those would give a specific type of permission to the user, to the IAM users, and what sort of capabilities he has on the specific stack and all the underlying resources beneath it. Of course, I can also choose to apply the existing IAM policies that are relevant to that specific IAM user. And something also very important, as I mentioned before, whatever you do applies to all the underlying resources. I can also apply SSH or RDP and enable sudo or admin privileges all the way down to the instance. That means I can have an IAM user have access, SSH access, and sudo privileges on a specific instance as a part of a specific stack. And this all happens directly through OpsWorks. You don't have to log into the instance, but if you do, we make sure that the IAM user has the relevant permissions. So in this scenario, you can have OpsWorks handle all the management, all the access management for your underlying resources for every stack that you manage. This is how it looks like from our console, where you can just click and have SSH enabled and sudo enabled, and this immediately applies to the instance. So after this happened, in our example, the user Joe Weiss can log into the instance within a minute. Something else that we offer in OpsWorks is temporary RDP session management. What this lets you, assuming that you have, let's say, a third-party consultant that wants to do some work on one of your stacks, you can let him have time-based or time-limited access to one of those stacks. So this is automatically revoked after that time period passes. Of course, very useful when you're working with third-party partners or consultants. Another thing that OpsWorks helps you do is monitor the health of your resources. We talked about how you have stacks and layers, and those are logical construct, logical wrappers to your underlying resources, to your application tiers. So we aggregate that sort of information and let you view it through our console. And what you get here is aggregated views on the layer or in a stack level, which is quite different than looking at individual resources. Using this, you can start answering questions like, how busy is my staging environment if you look at the CPU in general or memory? I can identify problems on a much wider scale than on individual resources. I can start looking at trends. Another thing that you get through OpsWorks is more than the hypervisor-based metrics that you normally get using CloudWatch. Using the OpsWorks agent, we push 14 free 1-minute metrics, which include CPU, memory, process count, and a lot more, to OpsWorks. So you can also view this and get more than just the hypervisor metrics. And all these, as I mentioned, are for free. And most importantly, as I said before, is the context. You get all these metrics, those 14 metrics, and you get them in the right context. You get them in the context of your application, the version of your application, or a staging environment, or whatever the stack concept means for you. Another thing that you get through OpsWorks is the ability to analyze logs. So let's assume you discovered a problem. What you normally do is you log into your instance. OpsWorks lets you do that because you defined SSH and sudo privileges, but you don't really have to. The way we see it is you don't really necessarily have to log into your instance because you can run commands outside of your instance without logging into the instance using those chef recipes, those arbitrary recipes that we can run at any time to mitigate any problem. And you can also get the logs without directly logging into the instance. The first logs we're going to talk about are the logs that you get once you do something called a chef run. So every time you execute a recipe called chef run, this has a result output. This is most relevant when you're developing those cookbooks and recipes, those Ruby scripts, to make sure they're doing what they're supposed to be doing. Let's say I want to work on how I build my web server, my web tier, and I start experimenting with those Ruby scripts. I start writing them, testing out what works and what doesn't. So I don't necessarily have to log into the instance. I can get the logs and the outputs and the results, whether it was successful or it failed, directly through our console. Something else we offer is a CloudWatch logs integration. Using this, you can also get your application logs available without logging into your instance. That means you can track any sort of problem that your application is experiencing without directly logging into the instance. So up to this point, we've been able to analyze problems using the metrics and process logs without actually using the ability to manage the access to your instances. That means that instead of having your entire team given access to a specific stack and all the underlying resources, you can start limiting permissions to who actually really needs to have access to the instances. Because all the things that are happening outside of the instance are completely trackable. So this gives you a lot more control when you're managing your fleet of instances, organized in stacks and layers. Now I'd like to talk about a close subject. Now, OpsWorks comes into play as a part of your continuous integration, continuous delivery pipeline. And we also have a service called CodePipeline that works together with OpsWorks. So before I go into how they work together and what sort of benefits you can get from using both, I'd like to briefly describe CodePipeline and what it does. So CodePipeline offers you a continuous delivery service that lets you run your application updates in a very, very fast and reliable way. What this means is that every sort of change that I make to my application, every sort of change that I push, gets automatically built. The artifact that is built gets automatically tested and is ready for me to deploy to production on a click of a button. So this entire process is now a part of a service that we call CodePipeline and is fully visualized. You can see this, and we'll demo this in just a little bit. And it's fully visualized, so you can see the progress and look at your pipeline as it's working, as your artifact works its way all the way from your build process, all through the tests that you're doing, all the staging environment in between, all the way up to production. And something also very important with this service, it integrates with third-party tools, which you're likely already using today, and with existing AWS tools, just like OpsWorks, which we'll demonstrate. So this is how, if you open the CodePipeline console, which we'll do in a little bit, this is how it looks like. We have an example application, and we have several, which has several stages. Now, each one of those stages is completely customizable. This is not hard-coded. You can define what the first one is, what the second one is, how many there are in between. In this specific example that we're looking at 3 specific stages: the source stage, the build stage, and the deploy stage. In each of those stages, we have something called an action. And in between, we have transitions. And it's, of course, also color-coded, so you can notice what state and transition your current pipeline is. So we also have the option to have parallel actions. In this specific examples, we're running a build using Jenkins on EC2, while also sending an SNS topic to our developers using Lambda, for example. There's also the option to add sequential actions. So same example as before, but after we're notifying our developers while we're doing the build, we're also running a test using RunScope, a third-party tool. So these are some of the third-party partners that we work with regards to every one of those specific stages: the source, the build, the test, and the deploy. For the source, we have GitHub. For build, we have CloudBees, Jenkins, Solano Labs. And as you can see, the list goes on, and this list is predated. We do support some more at this point in time. We also have internal service integrations. For the source, we support S3 as the source, code commits, which are our equivalent to GitHub, a source repository. We have invocation logic using AWS Lambda, which lets you define any custom action that you like, any arbitrary code to run as a part of your pipeline without having actual compute resources. I mean, if you want to run a certain code as a part of your pipeline, we'll let you do that in CodePipeline using a Lambda function that you can define at any point in time. And as deployment targets, we have OpsWorks, Elastic Beanstalk, and CodeDeploy. What is going to happen with what we'll demonstrate using OpsWorks is, we'll demonstrate how we're using OpsWorks to bootstrap the instances and deploy the applications. What actually happens is CodePipeline is going to instruct OpsWorks to run first the setup recipes when it bootstrap an instance, and then run the deploy recipes. Those deploy recipes will take the latest artifact from CodePipeline and will place it on the instance. And this entire process, end to end, will be orchestrated by CodePipeline. Now I'm going to jump to another screen to show you a quick demo of how this looks like. Okay, first of all, this is how OpsWorks looks like. It's quite simple to get started. If you want to create your own stack, you just click the Add Stack button. Well, you also see we have a Chef 11 stack and a Chef 12 stack. These are versions of Chef. And we also have a sample stack to get started really, really quickly. So let's assume I want to create one of my sample stacks, just to show you how it looks like. Click this button. So OpsWorks created a sample stack for me. This is the details of my stacks, the amount of layers I have, applications that I have defined, instances in the current state, and deployments and commands, which we'll get into. So the first thing to explore is the layers. In our case, we have just one layer, the Node.js app server layer, and it has one instance. So I can add additional layers at just a click of a button. I just need to name that layer. And as easy as that, I can just add another layer. If I look at here at recipes, I can see my lifecycle events that we mentioned earlier, the setup, configure, deploy. And of course, we have two that we haven't mentioned yet, which is undeploy, to undeploy your application, and shutdown. But basically speaking, you can do anything you'd like here. So if I attach the recipes, let's say bootstrap script, deploy script. So I can define those recipes over here. And what OpsWorks is going to do is going to take them from a specific repository that I defined for the cookbooks and apply those to that specific layer that we're in, my layer. We can also define the network configuration, attaching the load balancer to that specific layer. We have an integration with Elastic Load Balancer. And you can assign public IPs or Elastic IPs directly from here. We also let you define an EBS volume that will be attached to every single instance that you provision through here. And of course, there are some other security definitions that you can make here. So after you define your layers, you can start adding instances to those layers, either manually or automatically. So we have two layers here. We have our Node.js app server layer, which is right now stopped. We'll start that instance. And of course, I can add more instances to the custom layer that we just created. I can choose the instance type, which subnet is a part in, and of course I also have the advanced settings. In the advanced settings, you will see I have a 24/7 instance. That means that's an instance that I manually start and run for 24/7. Or I also have the option to do time-based or load-based auto-scaling, which we'll demonstrate in a little bit. You also have the ability to use existing OpsWorks instances that are part of a different layer. And you can also import other instances, which are not a part of OpsWorks and were not provisioned through OpsWorks, or even your own on-premises server that are sitting in your own data center, and attach them to that specific stack and that specific layer. So in this case, let's say I add another instance to that specific layer. in a stop state. One second. Okay, so what we're going to do now is we're going to demonstrate the time-based and load-based instances while this instance is booting. So in the time-based, if I choose add a time-based instance, I have the option to define the schedule this instance is going to be turned on and off in. So if I have predictable workloads, I can define the time that instance is going to be turned on or turned off in. I can also define load-based instances based on which metrics. So if I add an instance here, I can define a specific scaling configurations based on those metrics over here. So once I define my instance, I have my stack, it has layers, I've defined instances within those layers, with each layer depending on whether it's 24/7, time-based or load-based. I also have the apps. Now, apps contains my application and the source of that application, where it's sitting on. So in this case, I have a sample Node.js sample app, which sits on GitHub, and this is the location of that application. Every time I update that application and I click deploy app, OpsWorks will take that new code, that recent code, from GitHub and apply it to my instance using the deploy recipe. So the instance is still booting, and while it is still booting, we'll go to another example. You'll see here, we have a CodePipeline demo, which shows you the integration between OpsWorks and CodePipeline. Just like before, we have a Node.js app server, and it has just one recipe attached to it, Node.js demo, which will deploy my application on that specific instance, that single instance that is turned on. So let's see how this works. This is our pipeline. It's very simple. It's doing just one thing. It's identifying whether a change has happened to my source code, and as soon as a change happened to my source code, it's going to push it to OpsWorks and tell it to use the deployment recipe to take that artifact and place it on the instance. Now that deployment recipe will of course include all the necessary changes, changing symlinks, changing permissions, folder structure, whatever work needs to be done to apply that new code to the instance. Let's have a quick look at my application, its current state. So I just click this button over here. I'll see my application. This is my app, simple Node.js app. And now we're going to do some changes to the application and see how these changes get rolled out through CodePipeline and applied to OpsWorks using the deployment recipe. Okay, so to do this is our second version of our app. Just open it to show you how it looks like. So this is our application. I can change anything I want here, repackage it, place it on S3, and those changes will be automatically applied through the CodePipeline process all the way to OpsWorks, which will deploy using the deploy recipe. So let's assume I've done some changes to this application. I'm going to go to S3. I'm going to hit upload. Drag my file. And now you'll notice something very, very interesting happening. So what CodePipeline is going to do is going to pull an S3 to see if there's a change to the artifact And within a minute, once it identifies the change, it will start the process. It will take that artifact, will take this new code, and will apply to the instance using OpsWorks. And what we're going to see in just 1 minute is both of these services working together. Okay, so we're not going to keep waiting for the pulling. We're just going to release the change ourselves. I may have uploaded the older artifact. Let me re-upload a new artifact. Okay, so it seems to be still not processing my request, but what happens generally is the processes will now go into it will process this request and will apply to my environment. So once I go again and hit this refresh page, once I refresh this page, I will see the new version of my application working immediately. So coming back to our slide, what we're doing using OpsWorks is we're using it to update the cookbooks. And after we update those cookbooks, we use it to deploy our latest version of our applications. So let's assume that I first update my cookbooks and my application, which are defined together because my cookbooks define the configuration on the host. So my configuration includes things like what sort of dependencies are going to be used by my application, what's the folder structure, what's it's going to be, what's the permissions. So all those configurations will be a part of the cookbook, and it will live together alongside the application. And sometimes they will even be versioned together. So what I'm going to use CodePipeline normally for is to define both my application and the cookbooks themselves. So when I do the build, which may apply to my application, but will not apply to my cookbooks, I can use the same thing I've done before as you see in the example. And then from that point on, transition to the beta stage that I have built here that will apply the OpsWorks cookbook and configure my slate of instances with the most recent configuration. And then once all the dependencies are installed in every single instance, then I'll deploy my application using the deploy recipes, all orchestrated through CodePipeline and executed by OpsWorks. So how do you get started with this? The first thing you need to do is to learn about how community cookbooks look like. There's a very big community of open source community that keeps maintaining chef recipes, and there are several best practices that we recommend internally that are available in our documentation. I welcome you to go to the chef supermarket to try out some community cookbooks and start playing right away. If you'd like, as you see, we have a sample stack where you can spin up in just seconds and try out the Node.js application that I just demonstrated. And you can also visit our page to learn a little more about OpsWorks. And of course, OpsWorks together with CodePipeline.